Trench Sinking by Snowden Optiro. My name is Laurie Hassall. I'm a senior consultant based in our UK office, and today I'm joined by Julian Aldridge, who's our regional manager for the international region.
Hello.
Today we're going to be talking about copper. So this is another podcast in our commodity series. And if you enjoyed this podcast, then please subscribe to our YouTube and audio podcast channels. So this podcast is all about copper. So please inform us about copper and some of its uses and applications.
So the history of copper is as old as the history of humanity itself. It was one of the earliest metals that was used for any purpose by humans. Native copper has been found hammered out into sort of jewellery or primitive tool shapes up to sort of 10,000 years ago, and often associated with religious ceremonies, burial rites in places like central Turkey, Iran, Iraq, all those parts of the Fertile Crescent. So very much associated with the development of prehistoric human and the very earliest sort of human civilization development. Around 5,000 to 3,000 years ago was a huge step in changing human civilization, where the first metals were able to be extracted from ore by smelting, and again it was copper, which was the first and the easiest for humans, and that precipitated originally the Copper Age, and then of course the Bronze Age, allowing copper to be alloyed with tin, which created a much stronger, much harder, more durable metal, suitable for use as weapons and armour, and that precipitated essentially a global trade, or the start of global trade in metals, all stemming from the fact that copper was relatively easily winnable from ore.
And some of the properties of copper, why is copper so unique?
Well, I mean, copper is almost totally unsubstitutable. Unlike gold, it doesn't just have an appeal as a beautiful metal that can be used for jewellery. It actually has a lot of other uses. It's relatively hard, it's relatively durable, and I think the most important thing, and that has meant it's become as important to the modern age as it was to the prehistoric age, is the fact that it can conduct electricity. It has very, very little resistance to electrical flow. In fact, I seem to remember it's second only to silver. But unlike silver, it's far more abundant. It's much more easily hammered into wires. And it has a lot of properties that you need for something that's transmitting electrical currents and later digital information over vast distances.
So Julian, thank you for that introduction to copper. Moving on to geology then, what are the sort of geological environments that copper can be found in, and some of the deposit styles?
Well, I mean, copper's found across the world. We've both worked in copper deposits in completely different parts of the world. Yeah. I've worked in I've worked in exploration in Southeast Europe and the Middle East, Africa, and Southeast East Asia, all focused on either copper or gold, but predominantly copper. And it's found in loads of different geological environments. It's found as porphyries, so associated with intrusive bodies. It's found in massive sulfides, which can be associated with intrusives, or they can be associated with what are termed VMSs, exhalated volcanogenic massive sulfide deposits. They occur sediment hosted. Where have you?
Yes, so in the UK, they're vein hosted copper associated with other base metals. I have experience in that deposit style. But you're right, the range of deposit styles is tremendous with copper.
Yeah. I mean, I guess the best known places throughout the world are, of course, Chile and Peru in South America, famously mining copper there for hundreds and hundreds of years, and that's associated with the Andean mountain belt, the fact that there's a subduction zone underneath that from which you're deriving copper-rich magmatic fluids. Then there is, in North America, that was associated with again, subduction and also with some continental accretion, but again requiring copper-rich fluids to be associated with intrusive bodies very often. And then I guess the other big one is the Zambian and the DRC copper belts in South Central Africa, which I had the opportunity to visit last year. Absolutely amazing grades and occur over huge areas, and these are literally sediment-hosted chalcocite, almost blankets of ore. They're absolutely amazing.
And do you think there are any areas of the world that maybe have untapped copper resources and have shown great potential for copper production?
Absolutely. I think places that have previously been remote or perhaps politically unstable. But I think that there is pretty much everywhere in the world has got some opportunity for copper. I mean, it's that ubiquitous. It's throughout all different terrains, geological terrains, in some form or another.
Yeah, and because of the wide range of deposit types and styles, I'm guessing in terms of mining practices, it covers the whole spectrum. Copper.
Oh yes, yeah. I mean, copper exploration and exploitation is fairly sort of textbook. It's been something that's been around for many thousands of years. So there is a rich and varied history of exploring for and exploiting copper from the past up until the present day. I mean, even now you have companies making good copper-rich discoveries just in areas where previously people hadn't looked or had perhaps walked over thinking that there wasn't going to be anything there. And copper is very much found using classic exploration methods. You simply get out there, you map, you sample the rock, you sample the soils. Copper is very good in terms of its dispersal halo. It's very soluble, or at least copper salts are very soluble, and they will percolate out into the soils that form over copper deposits, and giving you a very, very good signature of copper or copper deposits that are buried beneath. In terms of mining, it runs the gamut from all types of underground mining to all types of open pit mining, because you can get copper deposits that can be, say, like a copper porphyry. I worked out in Reko Diq in Pakistan. That's 1 billion tons of copper, running from 0.3% up to 1%. I've worked on VMSs, volcanogenic massive sulfides, out in other parts of the Middle East, and they can be 5 to 10% copper. Almost 100% sulfides in some areas. So, I mean, very variable mineralogy. You have a bit of experience in copper processing. Does the geology and the mineralogy of the deposit affect?
Absolutely, yeah. I mean, you've touched on the wide-ranging different deposit styles that host copper, but in terms of the wide-ranging minerals that host copper, I mean, there's a length as big as my arm. It's the chief source of copper is obviously as sulfide as chalcopyrite, but obviously there are major deposits that exploit secondary coppers as well. But the mineral species, as with everything, we concentrate minerals, we don't concentrate metal. So and we recover minerals. So it's all important in terms of the unit processes that you select for copper recovery.
Right.
Obviously flotation is the chief amongst them.
Very effective for the sulfides.
Absolutely, yeah. And in terms of sulfide recovery, I think one of the aspects, obviously, with copper is usually you're going to have other sulfides with copper. For example, zinc, lead, arsenic, etc. And some of which is can be recovered as a byproduct. Some that you wanted to remove,
Some deleterious.
To purify your copper concentrate. And it's important to understand those minerals, how they are locked with your copper. Is the copper liberated? Is it locked with those sulfides? And that will determine obviously your grind size for your flotation and how you float those minerals.
So a lot of copper projects that I've worked on, as well as having one source of sulfides, have had multiple So where you have chalcopyrite, you very often have bornite, coverlite, and chalcocite. So in my experience, it's very, very key to get your geometallurgical model in place early on in the project in order to find out, in order to determine your processing route, because I guess not all sulfides are created equal.
No, exactly that. Floating copper minerals varies, depending on the reagents that you use differ entirely. So understanding what minerals are hosted in the deposit and where they are, how they're distributed, is really important to maximise that recovery.
Yeah, and I guess stoichiometry comes into play as well, because there's different proportions of copper within each of the sulfides. Like for example, bornite has the same, twice the concentration as chalcopyrite. So there's the old saying, one bornite is 2 chalcopyrites, but then 1 chalcocite is 2 bornites. So for the same sort of weight percent that you have of chalcocite, you've actually got 4 times the amount that you would have in chalcopyrite. So just means that the sort of the stoichiometry of the mineral species is going to have to be taken into account.
Yes, absolutely, and that dictates grade at the end of the day as well as recovery. Yeah, absolutely.
Okay.
So in terms of estimating copper, is there anything that's different about copper, resource estimates, and anything you need to be aware of?
Yeah, that's a good question. I mean, copper is relatively straightforward in terms of estimation and in terms of making sure that your data quality is there, because it just has a very established history. It's well understood mineral, and its distribution is pretty well understood. I think the key things with it are that each of the deposit types are unique, and therefore the estimation methods are different. Quite commonly, you would use a different technique for modelling porphyry than you would for, say, modelling a VMS. A VMS, the contacts are usually very, very clear. You go from several percent copper actually in the ore body, in the sulfide unit itself, to virtually nothing in the host rock, and that's usually a very, very quick contact, either over a metre or so, or can even be less, can be direct, very sharp contact. But within a porphyry, something like that, the actual grades will tend to sort of slowly or gradually die off towards the edge, associated with the different alteration phases, fluid cooling throughout the process of, throughout the process of these intrusive formations, and this sort of overprint you get with cooler fluids with a larger meteoric content will have a tendency to actually destroy copper mineralization. So you need to consider things like hard versus soft boundaries.
So your boundary analysis is very important.
Yeah, that's very, very important. Also looking at things like indicator creeding. You can decide, okay, at what point do I consider my copper grade to be economic versus it to be uneconomic? And that's something that you can do using indicator creeding with different cut-off points in it.
Yeah, and you found that to be very useful in the past.
Yes.
Mineral resource estimates.
Absolutely. I found that. Yes. It's certainly been very useful for copper estimation. Estimation within intrusives as well, even for other elements as well.
Yeah, nickel laterites being another.
Yes. Yeah. Absolutely. Yeah, you can use indicator creeding for that, or you can subdomain.
Yes.
So yes, lots of different options. In terms of, I guess, talking about supply and demand of copper and the idea, and how it's likely to change in the future. What are your sort of views on is the future bright for copper?
Well, it looks over the moment. I mean, at the time of this podcast, copper is the price of copper is on the upward trajectory, and it's a technology metal. At the end of the day, it's used in everyday life, but it's also a metal that's all important for the technology, for new technology. In terms of our sort of battery revolution and electrification of the automotive industry. copper is integral.
Yeah, we certainly don't have anything to substitute, low resistance transfer of electricity over long distances, do we? So there's always going to be that fundamental infrastructure demand.
Absolutely. And what's your opinion, Julian?
Well, I'm of the opinion, I'm quite sort of bullish on copper's outlook, I think is the best way of putting it, because I'm hopeful that this uptick in price is the start of the big one, the start of the 100-year-long second industrial revolution that we're sort of heading towards. Where we're converting from using fossil fuels to using renewable energy and actually having a cheaper alternative that's environmentally far less damaging. And I'm hopeful that this is the start of the big one. Yeah. Not just on account of the fact that it means that the industry in which we work will have the opportunity to develop, but I think also the fact that we can start to ameliorate some of the damage that we're doing to the planet as well.
Absolutely.
Yes.
Yeah. So that draws this podcast to a close. Julian, thank you for providing us with this great insight into copper.
No, thank you for having me.
Yeah, really interesting. If you'd like to listen to more of our Fresh Thinking by Snowden Optiro podcasts, you can find them for free on our website and on all the other podcast platforms. If you enjoyed this podcast, please subscribe so we can keep you up to date with all our other technical podcasts in the future. Thank you very much.
Thank you.